Hey, scour mitigation strategies used in Washington State, and I'm going to try to put a little preventive maintenance spin to this one. I did this a number of years ago, and as Dwayne will tell you, we don't do very many scour repairs, not because we don't need to, it just takes years and years and years to get the permits. So that's why it takes a long time, and oftentimes some of these smaller scour repairs, it actually costs more to get the permits than actually do the work. That's kind of a strange thing, but it's the truth. Washington State catastrophic bridge failures. Unknown, there were two, and I can't trace those two back. Tsunami. We actually had two out on Highway 109 next to the coast due to the earthquake up in Alaska, 9 point something or other up there. And it took two timber bridge spans out. Storm or wind, I think everybody knows of one. That's our Tacoma Narrows Bridge. We also lost the Hood Canal Bridge with 100 and some mile-an-hour winds, and the pontoons sank. The I-90 not floating bridge anymore sank while it was being rebuilt and repaired. The contractor had left openings in the side of the pontoons, and they filled up and sank one day. Overload, and there's one here I like to, was it a truck? Was it, what caused the overload on this one timber bridge as a timber truss back in 1949? It was a flock of sheep crossing a timber truss bridge, and it failed the bridge. Another one was up on Highway 20, which is now Highway 20 now. They discovered that after they plowed the road in the winter. It was a snow load that overloaded the bridge and failed it. And the third one, I don't know which one that was. Collision, had a number of those, usually overheight loads. Volcano, we had Mount St. Helens, took out 5 of our bridges. Fire, usually those were done during some kind of contract work. Usually a timber deck and trying to adjust things with a torch and not having a water supply on hand. About 3 of those occurred. But the most common reason why we lose bridges is from scour, and that's 61% of all our catastrophic bridge failures. Preservation actions is, first of all, keep large woody debris from building up on your piers and maintain any scour preventive measures that you've already put in place. Besides catastrophic failures, I think we lose a lot of bridges not from something that happens all at once. I think we lose a lot of bridges just from neglect because we don't do our preventive maintenance. Bridges don't last as long as they should. And things you should really focus on are your joints. Keep your substructure and superstructure intact. Bridges that aren't painted on time that lead to section loss and pack rust. Timber rot not addressed, leading to sub and superstructure failures. Decks not sealed, leading to deck failures. And I really believe we lose more bridges because of that don't last as long as they could. Some people build bridges for 30, 35, 50, 75 years. They should last hundreds of years with the proper maintenance. Another one is design, and to try to keep piers out of the water, best you can on your design. And do not use spread footings for bridges in active waterways. And I'll show you some examples of those. If you are told that you are only funded for spread footings, push back. These will cost you in the future. Use deep shafts, then piles if piers must be in the waterway. What we use mostly is armor on our bridge piers when we repair them. Here's an example. This is on the Hump Tulips River Bridge. And here it is. As a story on this one, this bridge we were trying to get permits for over 4 years to armor this because it's on a spread footing. It had failed back in the 70s, and we'd armored it. Over time, we didn't keep track of the pier protection that was there. We didn't maintain it. It washed the rock away. And so we were down to getting within a foot of the base of the spread footing. So we were getting really nervous. We couldn't get our permits, but I found a plan sheet that showed the repair back in the 70s. And if you're just putting back what's there, you can get a permit pretty quick. So we actually mobilized our maintenance forces, They went out, and if you look way up in the back, there's a little roadway in there. That delayed the project 3 months because we didn't have a permit to put a roadway in within 300 feet of a waterway. So it took a lot of convincing. So we didn't actually get the work done until around September, and we armored it pretty good. And this was it about a month and a half after we put the pier protection in place. One of the biggest floods that we've had through the Untitled River area. It's one of those just in time. What was also supposed to be put on the Untitled River, which was done later on in contract, are barbs. And I've always been amazed at how well these things work if they're built properly. They do move the force of the water away from important parts of your bridge. I don't know if you can see, but look kind of in the distance, there's some little rock piles off there. And those are where the barbs have been put. The other thing is, if you notice a little roadway that went to the pier protection that we put in place, important thing is leave those there because you're going to have to get back in if you want to maintain your pier protection. Also, if Oregon, Washington, we have a lot of large woody debris called trees, and they build up on the piers, and they require removal. And it's much better if you can drive down there under the bridge and remove them than have to take traffic up on top and try to reach under the bridge and pull the logs out. So we got a permit to leave those in place. This is Michelle River Bridge on State Route 161. This is actually a plan I got from the Nisqually River Tribe because they had put in some engineered log jams up above one of our bridges. It's amazing how easy they can get permits and how hard it was for us to get ours. They do a little different type of an engineered log jam. Just below, if you go to the left on the picture, that's the Michelle River Bridge. They were protecting, if you look above it, there is a mill pond, which is up above there, and the water was eating away at the base of this, and the mill pond is actually quite elevated. And the fear was that it was actually starting to leak, so they needed to protect that. They didn't want the mill pond to breach and flood into the Michelle River. So that's the reason why they put it in, also as a means of enhancing fish in the river. Well, here's the Michelle River Bridge. This was built, I said, in 1981. If you don't remember, those of us, you are too young, we had a recession in 1981. And because of that, we cheapened up our bridges. Like just about every bridge we built in 1980 to 1983 were built on spread footings. Didn't matter if they were over a highway or in a river or a stream. We built spread footings because they were much less expensive to build. And we've been paying for those ever since. So you can see the abutment here was being scoured out. Also the center pier was scoured out, and had maintenance forces go in and put in some rock temporarily to preserve the bridge. Something we found that works pretty well is we usually have to isolate our work area. So we went out and bought a number of these water-filled barriers. Kind of isolates your work area from the river or the stream. And they work fairly well. They're not fun to wrestle with, though, especially when you're trying to get the water out. You need a crane or something to lift up one end to drain those things. Then you have to roll them up. Another thing you have to do is once you've isolated the area, you have to go out and check for little fishies. And so out there with our permitting people, actually we had the tribal members come out too, and that apparatus on his back is used to sting the fish. It paralyzes them, then you can scoop them up pretty easy. So that's what they're doing. They're putting the fish in their 5-gallon buckets and putting them in a safe place. One thing we found, and I learned this from an old hydraulics engineer, is look around, see what rock is still in place after floods, and get the rock bigger than that. and then you can be fairly sure it's going to stay there. So this is the kind of rock we put in place, so big stuff. You have to dig down, make sure you key your rock in place. Here was the north abutment of the Michelle River Bridge with the rock in place. We also did the center pier out there, because it was a scour hole. It was also on a spread footing. And if you look to the far right on this picture, that's the tribe's engineered log jams. And in between that pier and there, we had a contract to put in engineered log jams. Ours, we drilled down, we put in steel, and we had to embed them 5 feet into bedrock. The contractor had a terrible time doing that. He was getting maybe one done a day. He lost a lot of money on this one. That was the south abutment. We did both abutments and the center pier. Another thing we use, or are required to use, or put in these log jams. I put this one in because you have to watch out what you're doing. You notice this looks kind of like a tank trap with the logs sticking out. And the reason why I put this in is we had a kayaker that was killed when they got caught up in these. So we went out and trimmed those things down. This is the whole river bridge. The problem with this one is not a bridge, but it was attacking the US 101. And we had been dumping large rock in place, and the river is very active, and these were Volkswagen-sized chunks of rock, and it was moving them. So we had a hard time keeping those in place. So we had to find a better way to kind of take care of the river, to keep it from washing out our highway. A little closer look at it. If you look up to the top, that was some of the rock that was left in place, and it had gotten in behind it. And what we decided to do is put in engineered log jams. We put quite a few. These are used to roughen the bank, kind of move the force of the water away from the highway. Another look at them. Close up, looking at the ELJs along the bank. We use very large logs through there. We try to get the best stuff we can. They cost, believe it or not, about $2,000 a log on site. And we also, you put out islands, ELJ islands, out in the middle of the whole river. It was interesting just getting out there to build these. Again, we drove deep piles. So these things aren't going anywhere. And they do work very well at diverting the river away from the bank, taking some of the force away. Here's one of the islands. They kind of fill in around them over time. Lessons learned. First of all, develop a really close working relationship with the tribes, habitat biologists for fish and wildlife. Use large rock with good degradation numbers. We've tried in the past with our maintenance force just getting the nearest quarry and drop the rock in. When the rock breaks up as you're dropping it, you know it's not going to last. Key in the rock. Maintain your access roads if you're going in there to do the work, because you're going to have to come back at some time in the future. So keep those in place. And permits are hard to get anywhere near a waterway. So again, keep those access roads in place. Armor, barbs, and ELJs do require maintenance over time. Keep your as-built plans on file, because they will save you in the long term. Again, because if you're going to go try to get a permit, if you can show that all you're doing is putting back the material that was there, that was lost, you can get a permit fairly quickly. This is questions, but I want to point out that one of the things we were allowed to do across this Michelle River here, this is upstream from the bridge, is we were allowed to build that little canal so the water could be diverted. We put in our those big water-filled tubes to dam off the river so we could do work downstream from there. And the river does a loop through there, and then we could force the water through this little canal. And then the Fish and Wildlife said, would you just leave it there? Because it provided additional habitat for the fish. So any questions? I don't know, Dwayne, how much backlog do we have on our scour repairs? We have quite a few. Our main problem is just getting permits.
Yeah, we have over 300 scour critical bridges, but what we do in Washington State is we go through and look at each one of those and then assign a risk to determine what we need to do and if we need to do it. And currently we have 3 programmed out of that pile, because the rest of them we are monitoring, and there's other things that we can do instead of going out there and spending millions of dollars that may or may not be worth it.
In the back, from David Evans Associates there.
You talked about routine and regular maintenance on the log jams. Do you guys have a regularly scheduled program for that, or is it just upon inspection, if it's, let's say, close to a bridge, upon a bridge inspection, you see deficiencies associated with it, you address it there?
Yeah, for the bridges, because we do our inspection, they're taking a look. They'll make note if we've lost rock or whatever else in the area. So then we'll try to get back in and do them, try to keep the rock in place, look at the barbs, make sure they're still functional out there. Mostly what we do around the bridge piers is just remove large woody debris.
What's the advantage of log jams over just a bunch of large angular rock in that area?
Permits. They're a lot easier to permit. The agencies out there like them. They think they're much more friendly to fish. And I said permits are probably the hardest thing to do when you're looking at scour repairs. Any other questions? Okay, thank you.